Hello, my friends. Today we're going to discuss a dramatic story, but one that contains absolutely extraordinary lessons. By the way, if you're a private pilot, watch this video until the end, talk about it with your instructor, because it could save your life one day. So, we have this story that will begin in July 2023. A Piper 23 aircraft, that's the Piper Aztec, it's a twin-engine propeller plane, is going to take off from a small airfield in the north of England, a small airfield with a grass runway called Bagby. It takes off from Bagby, heads south to reach Deauville. On board, there's a 21-year-old pilot who, technically speaking, isn't allowed to fly this plane. He's an aviation enthusiast. He's been going to flying clubs since he was 12, but it seems he wasn't trained to fly this aircraft. Nevertheless, he's going to fly it. So he's going to arrive in Deauville and he's going to take 4 passengers. From the horses area, he heads up towards Ireland, where the weather is marginal, as is often the case in that country. He still lands, probably he did some wild IFR instrument flying. Afterwards, he takes off again on his own to return to Bagby at the end of the afternoon. And here's what's going to happen. He's turning onto base, which means he's 90 degrees from the runway axis. He has about 1 or 1.5 minutes left to land. So he's at about 1,000 feet. Suddenly, here's what the witnesses on the ground will see. And here's what the surrounding surveillance cameras will record. The Piper Aztec, the aircraft, will suddenly dive, reaching up to 40 degrees with the nose below the horizon. And it will shoot toward the ground like an arrow. At some point, it will almost seem to recover, only to dive again even more sharply, and then hit the ground violently and explode. The pilots who are on the ground get into their vehicle, rush to the spot less than 2 kilometers away, and then they see there's nothing they can do. The firefighters arrive at the scene and the aircraft is destroyed. It caught fire. The pilot was ejected from the cockpit, and 34 meters away, he passed away. We're starting an investigation, and what I'm about to say is truly extraordinary, because usually an investigation into an accident like this wouldn't have gone very far. Because generally, the British Accident Investigation Authority, what it does is look at the public interest, the interest for aviation. Here, in all likelihood, we have a young pilot who was flying an aircraft he wasn't qualified for. We can say he lost control, end of story. We can write a report. In 3 days, we write a page, take a few photos, ask some questions to the witnesses, and then goodbye. No. Now, the Accident Investigation Office will find out that with the Piper Aztec, there are a number of troubling incidents. Un nombre d'événements troublants en répétitif. They go back 20 years to 2002, for example, in the United States, where many of this type of aircraft were produced and are still flying. Well, they will find an example, a Piper Aztec flying at about 4,000 feet. There's a radar, it's under radar control. The radar at 4,000 feet, there's a radar, it's under radar control. The radar completes a sweep every 12 seconds. On the next sweep, the aircraft has lost almost 2,000 feet suddenly. The radar makes another sweep, and this time, the aircraft has lost almost 2,000 feet suddenly. The radar makes another sweep, and this time, the aircraft is not directly over the radar. It has crashed, and it's found wrecked in a lake. And in fact, over time, when they search through the databases, they discover more and more similar accidents. And that's what justified the efforts that were put into this investigation, which was extremely, extremely detailed. They even went as far as borrowing a similar aircraft, bringing back deceased pilots and trying to recreate the fatal flight. So what are we going to discover in the wreckage, the debris? There's nothing unusual. The propellers are twisted, they're corkscrewed, as we say. That means they hit the ground while they were being driven, each by its engine at high speed, so the engines weren't out of order. The cameras don't show that there was a fire before the impact, so all the fire broke out after the impact. There's just something that's going to catch their attention. It's that the elevator trim was almost completely set. It was 3 away from the nose down stop. So here we think the guy is flying. He's controlling his plane very well, it seems. and then suddenly the trim, which actually can be managed in two ways, well, three ways. There's a button on the control stick. If you push the button, it means you want the trim to go nose down. If you pull the little button, if you pull the button towards you, you raise the nose. The point is to lighten the load. You don't fly with the trim, but the point is to reduce the effort. On the C, on the elevator, there's another way. There's a crank above the pilot's head. He has a crank that can turn one way or the other. And then there's also a third point, which is that there's the autopilot. This aircraft is factory equipped with an autopilot that was placarded. Inoperative means that the maintenance services considered that this autopilot was not working properly. They didn't know how to repair it. It was an extremely old model. What did we do? We said it's inoperative and we left it there. So this autopilot can also control the trim, that is the pitch trim. We're going to start running a number of tests, and this debrief will open our eyes to the numbers. When we look at aviation regulations, when we look at aircraft certification rules, well, those rules involve a lot of numbers. We accept them as absolute truths without really questioning where they come from or if they have any real meaning. The aircraft manuals also contain numbers, and we take them as absolute truths as well. It comes up in exams, the instructor might ask questions, all that, but in reality, where does it come from? And this investigation, and that's what's extraordinary, is that it will dig into the numbers. The first number they dug into is that they realized we're probably in an out of trim situation, what we call trim runaway. That means the trim inadvertently, because there was a fault in the autopilot, there was a short circuit somewhere, the trim motor drove it all the way nose down completely. Let's review this aircraft certification rules. What do we find out? We find out that, well, there are a number of figures given about the weight, about the maximum force you can tolerate on the controls during out of trim situations on a light aircraft. Well, I'll give you one of the figures. There are several depending on the configurations and situations. For example, one of the figures says that when you have a control stick, you shouldn't have more than 60 pounds of force in case of a trim problem. We're talking about 27 kilos. That means they say 27 kilos of force. We shouldn't exceed that. There shouldn't be a situation where, with the trim completely out of whack, you get a force of more than 27 kilos. That's what the regulations say. That's something that is normally checked during the certification of the aircraft. We read it, we're happy, we repeat it. If it comes up on the exam, we check the box so it doesn't come up again. But where does this number come from? What does this number mean? Why 60 pounds? Why not 50? Why not 30? Why not 200? Where do they come from? That's it. So they're going to look. They'll discover that this number appears in the American regulations from November 1st, 1949. So it's old. Afterwards, the ANFA, which means it's the American equivalent of the DGSE. So the American ANFA will update the regulations many times since 1949, except that each time they will use the same numbers from that era. Well, if it says 60 pounds, I put 60, that's all. Even worse. When the European agency ESA was created, what did it do? It took the same numbers from the FAA, which themselves date back to 1949. So we use them again without ever really analyzing whether they're justified. It's what we would call in cooking cross-contamination. So there is a company that in 2019 will carry out a number of tests. They said to themselves, well, let's take a lower number. Instead of saying 60 pounds, let's be generous and say 50, we'll take 50 pounds, which is about 23 kilos of effort. And we're going to bring people in, we're going to bring in volunteers and put them in a sort of, we're going to seat them on a chair. We'll give them airplane controls that are connected to measuring devices, to a computer, and we'll tell them, okay, you're going to apply a force of more than 50 pounds instead of 60, so 23 kilos for more than 3 seconds. That's what we're asking you to do. With one hand on a control stick, for example, you'll pull on the stick with a force of more than 23 kilos for 3 seconds. And what they're going to discover is absolutely extraordinary. The reality is that 68 of the participants are unable to do it. Only the rest, so the remaining 32, are able to do it. So the third who managed to do it, while the other two-thirds can't do it. Even worse, in the group of women, 90 are unable to provide this strength. So we wonder how they were built in the 1940s, but obviously they were much stronger than us. So these numbers that are tolerated or used by regulations up until now, there are several numbers like 60, 70, depending on the situation, are actually too high. But we adopted them without ever questioning them. So that's already the first point. Secondly, autopilot. It's written in the airplane manual that the autopilot, well, if it ever, let's say, goes haywire or does something wrong and the pilot wants to counter it, well, it's designed with a friction clutch system. That means the pilot can, by applying this force, the force is estimated in the manual to be around 4 to 7 or 8 kilograms of force, act against the autopilot. A clutch system, just imagine, for example, a shaft, and instead of having just one shaft, well, you have a shaft with a friction system, right? Okay, between the two parts. And then if there's too much force, the two parts can turn independently of each other. You see, that's a clutch system. Well, of course, in the manual, it looks very good. From 4 to 8 kilograms, it's reassuring. Everyone thinks, well, 8 kilograms isn't the end of the world. When they look at the companies that do maintenance for this type of aircraft, they're going to notice something terrible. It's that in 25% of the planes, when tests are done, they realize that the autopilot, its clutch system, is not properly configured. And it has a much higher resistance than the 8 kilograms stated in the manual. So there's a number in the manual, but in reality, that's not the case. Even worse, we realize that in 6 of the planes, brace yourself. The weight, the force needed to counter the autopilot exceeds, this is not a mistake, exceeds 100 pounds. That means we're talking about 47 kilos or more. Knowing that at 50 pounds of force already, 90% of women are out. 68% of the mixed cohort are out. So when you double it and go to 100 pounds, so 47 kilos of force, you have almost no one left. It's an extremely high force. It's a very high resistance that doesn't allow a pilot to counter it. You see, so between what we see in theory and what we have in practice. By the way, if all these numbers were correct, if all these regulations worked, this channel wouldn't exist. So it's actually during accidents, during these debates and debriefs, that we discover these problems. Now they bring in a pilot, they go up with an instructor, and they start running tests. They realize several things. It's that when the trim runs away, if the trim starts to unwind nose down by itself, well, the real way to handle it is to pull the circuit breaker. There's a circuit breaker. So on the right side, so the pilot sits on the left. When he's alone, he sits on the left. On the right, there are a number of circuit breakers, what we call, well, we don't really call them fuses. That's a bad translation on my part. They're circuit breakers. They're circuit breakers. You know, they're things you can pull and push, you see. And when you pull them, well, you cut the circuit. And when you push them back in, you put them back in place, the circuit is closed, you see. So ideally, what you need to do is find the little button and pull it. The problem is, it's not easy because they all look the same. So there's a little writing on it, a small text, but since the plane is from the 70s, well, the text is already very badly damaged. So what do? Do you fight with the controls or do you let go of the controls? They did that. They ran tests and they realized that, well, most of the pilots who went for the circuit breakers in the end lost control. Quite simply, because you can't let go of the controls, the plane is tipping, and you go looking for the circuit breaker. On top of that, those fuses all have the same color. So what they found is that some owners, what they did was install colored heads. That means for things like trim, it's very important. They were adding colored plastic caps for trim and autopilot, but the factory didn't include those. They also discovered that on some people would put a cloth. So they would take a cloth, wrap it around and tie it. That way it allowed them to pull and take it out. But the really serious mistake is that from the moment the autopilot was considered inoperative and couldn't be repaired. Why didn't they deactivate it? Unfortunately, there are several things that aren't taught in the clubs. I've flown myself in flying clubs where they tell you, yeah, don't use the autopilot, it doesn't work. But it's still active, it's still connected. Its switch and its circuit breaker are still connected. You see, they're not going to go and disable it. So the risk of activating it inadvertently or by mistake or something else is still there. And from there, it can actually open Pandora's box. We also realized that the pilot was not wearing his seatbelt. So the problem is that at the moment when the plane tips over, when the plane suddenly decides to go into a dive, potentially what this pilot can do is he can be thrown around the cockpit. Because when you have negative or zero Gs, everything floats. And if the pilot isn't strapped in, he can end up floating in the cabin. And this doesn't make it any easier to regain control of the plane, because the whole point of the seatbelt isn't necessarily about an impact. It's also about being firmly strapped to your seat. And in the event of sudden and severe turbulence or a sudden loss of control, the pilot doesn't end up in the back seat. You see, there's that problem too. So they're going to talk to pilots who have had this problem and who managed to get out of it. And now I'm going to give you the method they used. It's not a certified method, it's not approved, it's not taught. Runaway trim is not taught at all in flying clubs, and yet it was a very significant risk that kills people every year. So here's what the pilots who made it out did. When they saw that the trim was unwinding by itself and moving and they couldn't stop it, they used the battery switch, the main switch. There's a big button on airplanes, on off. When you turn it on, what happens? When you get into a private plane, this button is set to off. Sometimes it's one button, other times it's two stuck together. We press it. So what are we going to do? We're going to connect the electrical circuit. And at that moment, the instruments turn on, the screens light up, the plane starts to come to life. We start to hear the gyroscopes whistling and all that. So what they did, since it was very hard to access, they didn't have time to reach the fuse. They took this button and pushed it to off. What happens when you do that? All the electricity in the plane shuts off. The engines themselves don't stop, because in a plane, the engines don't depend on the plane's electricity. Well, they do depend. The starter, of course, depends on the battery when you start for the first time. But once the engines are running, they're completely independent of the plane's electrical system. So the engines will keep running. The controls are cable operated. They're not electric controls or anything like that, so there's no problem. It's just that we lose the radio. All the instruments turn off, etc. At least the instruments that are digital turn off. But aside from that, the trim stops completely. So what the pilots did was press the big red button, cut the power, regain control of the plane, reset the trim where it needed to be, and calmly found the fuse, removed the stop. And only after that did they restore the power. And then everything, the whole dashboard, everything comes back on. So that's it. This pilot was 21 years old. He had been training because he wanted to become an airline pilot. He had been training since he was 12, literally. He used to go to flying clubs. And he ended up trapped by this problem, which is known on this type of aircraft, but can happen on any light aircraft equipped with an autopilot and electric trim. And unfortunately, once again, it's very sad to see that this is never taught in flying clubs, that people can move on to these planes. Because this pilot wasn't trained on this aircraft, but even if he had been trained, it wouldn't have changed anything. It's not something that's properly covered. Thank you for watching this video up to this point. Thank you to those who support this channel by subscribing to the premium section, and also by subscribing on Patreon, which also gives you access to exclusive videos that are not public. Thanks again. See you in the next video.